Hello everybody, welcome back to my channel. If you are new here, then consider subscribing because I post process control engineering related videos regularly. Today we'll be looking at some of the instrumentation interview questions and answers. So if you have an interview coming up for an instrumentation or process control engineer position, then this is a video that you need to watch. Also, I've recently made a couple of other videos on process control engineering interview questions, so make sure you check those out as well after watching this one. Okay, let's get started with our first question, which is, what is a control valve? Now, if you are going into an instrumentation or process control engineering interview, then this should be a very basic question. You should know what a control valve is. So in simple terms, a control valve is basically a type of valve which is used to control the flow of a fluid by varying the valve's opening. The primary function of a control valve is to regulate the flow of a fluid in a system by precisely controlling the amount of fluid that can pass through it. Okay, so this is a really important point. The valve regulates the flow of the fluid by varying the valve opening. And depending on how much you want to allow the fluid to pass through, so depending on the flow rate requirement, you will open the valve more or less. So if you want more fluid to pass through, you will open the valve more, and if you want less fluid to pass through, then you will close the valve more. Control valves are essential components in various industrial processes, such as chemical processing, oil and gas refining, power generation, and HVAC systems to maintain desired process conditions and product quality. They achieve this precise fluid regulation by utilizing actuators, which are generally electric motors or pneumatic pistons, to adjust the valve's position according to signals from control systems. By manipulating the valve opening, control valves can modulate the flow rate, pressure, temperature, and other process variables within specified limits, ensuring efficient and safe operation of industrial plants. Okay, so hopefully you understand what a control valve is and how it works. Our next question is, what are the different types of control valves? There are several types of control valves available, and they are categorized based on their operating mechanism, flow characteristics, and other factors. Here are some of the most common types of control valves: globe valves, gate valves, butterfly valves, ball valves, diaphragm valves, and more. Each type has its own unique features, advantages, and applications. Globe valves are known for their excellent flow characteristics and tight shut-off capabilities, making them suitable for applications requiring precise flow control and throttling. Gate valves offer minimal flow restriction when fully open, providing efficient flow passage, but may not be ideal for throttling due to their design. Butterfly valves feature a rotating disc for flow regulation, providing quick opening and closing times, and are often used in large diameter applications. Ball valves utilize a hollow ball for full flow when open and offer good shut-off capabilities, but may be more susceptible to leakage. Diaphragm valves employ a flexible diaphragm to control flow and are suitable for corrosive or abrasive fluids, as the diaphragm isolates the wetted parts from the actuator. Other types include check valves, which allow flow in only one direction, and solenoid valves, which use an electromagnet to control flow. The choice of control valve type depends on factors such as the specific application, fluid being handled, operating conditions, and desired performance characteristics. Okay, so these are some of the most common types of control valves. Our next question is, what is a PLC? So PLC stands for Programmable Logic Controller, and it is an industrial digital computer used for controlling machines or processes. A PLC is a ruggedized and versatile device designed to operate in harsh industrial environments where traditional computers may not be suitable. It typically consists of a central processing unit, input and output modules, a power supply, and a programming device such as a human-machine interface, or HMI. PLCs are commonly used in manufacturing, automation, and process control applications, where they can perform repetitive tasks, monitor process variables, and make decisions based on predefined logic. They can control motors, sensors, actuators, and other devices to automate processes, ensuring safety and efficiency. PLCs are also used in various industries, including automotive, food and beverage, packaging, and more. So yeah, this was just a very basic definition of what a PLC is. The next question is, what are the different types of PLC signals? So there are various types of signals used with PLCs to communicate and control processes. These signals can be broadly categorized into two types: discrete signals and analog signals. Discrete signals are used to represent binary values such as on or off, true or false, high or low, etc. These signals typically consist of digital values like 0 and 1 or low and high voltage levels. Discrete signals are used to control devices such as motors, lights, solenoids and switches, where a device either operates or is inactive. They are also used for sensing and monitoring purposes, such as detecting the presence of an object using a proximity sensor or monitoring a limit switch to determine if a machine has reached its end of travel. On the other hand, analog signals represent continuous values such as temperature, pressure, flow rate, etc. These signals typically consist of varying voltage or current levels that correspond to a specific process variable. Analog signals are used to control processes that require precise and proportional adjustments, such as temperature control, pressure regulation, and flow measurement. They are also used for data acquisition and monitoring purposes, such as recording temperature or pressure values for analysis or display. Here are some of the most common types of signals used with PLCs: digital input and output signals, PWM signals, analog input and output signals, CAN bus signals, Profibus signals, and more. So these are some of the different types of signals that can be used with PLCs. Our next question is, what is a temperature sensor? A temperature sensor is a device used to measure temperature and convert it into a measurable signal, such as a voltage or current, that can be read by a controller or other monitoring device. Temperature sensors are essential components in various applications where temperature monitoring and control are required. There are many different types of temperature sensors available, each with its own working principle and applications. Some of the most common types include RTDs, resistance temperature detectors, thermocouples, thermistors, infrared temperature sensors, etc. Each type has its own unique characteristics, accuracy, and temperature range. So, for example, RTDs are known for their accuracy and stability over time, while thermocouples offer a wide temperature range and fast response time. Thermistors are small and compact, and infrared temperature sensors can measure temperature without direct contact. The choice of temperature sensor depends on factors such as the temperature range, accuracy requirements, environment, and application constraints. So these are some of the different types of temperature sensors that you can choose from. Our next question is, what is the difference between a temperature sensor and a thermocouple? So this is a very good question, and you need to know this. So as I already mentioned previously, a thermocouple is a type of temperature sensor. In other words, a thermocouple is a temperature sensor. However, the reverse is not true. Not all temperature sensors are thermocouples. There are various types of temperature sensors available, as I already mentioned, such as RTDs, thermistors, infrared temperature sensors, etc. But among these, a thermocouple is a temperature sensor that uses the Seebeck effect to measure temperature. The Seebeck effect is a thermoelectric phenomenon where a temperature difference between two dissimilar conductors or semiconductors generates a voltage. In a thermocouple, two different metals or alloys are joined together at one end, forming a junction. When the junction is exposed to a temperature difference, a voltage is generated. This voltage is then measured and converted into a temperature reading. So yeah, this is the main difference between a temperature sensor and a thermocouple. A thermocouple is basically one type of temperature sensor. So these were some of the instrumentation interview questions and answers. Please let me know in the comments below if you found this video helpful. If you did, please hit the like button and share this video with your friends. Also, don't forget to subscribe to my channel. Thank you very much for watching this video till the end, and I'll see you soon in my next video.